Hello, and welcome to another mini video, mini lesson to understand basic concepts of chemistry. In the last video, I'll show you how to represent chemical reactions as chemical equations. In this video, I will show you how to balance those chemical equations. Let's start with the chemical reaction of ethane that we showed in the last video. Ethane reacts with oxygen gas in a combustion reaction to produce carbon dioxide and water. The point of balancing chemical reactions or chemical equations is that you must not violate the law of conservation of mass, which states that matter is not created nor destroyed. It only gets transformed. So, a balanced chemical reaction means that it has the same number of atoms and types of atoms in both sides of the chemical reaction. It is not possible to have more atoms in one side than the other because you will be creating mass or creating matter from nowhere. So a good way to balance these chemical reactions is to make a list of the elements that appear in both sides of the chemical reaction. So in this case, we will make the list of carbon, hydrogen, and oxygen, which are the elements that are present in our chemical reaction. I like to draw these lines just to show that I'm gonna count the number of atoms that belong to each side of the equation. So in the case of carbon, in the left part, we have two carbon atoms represented by this C2. So I will write the number 2 here. Now, in the case of hydrogen atoms, I have 6 hydrogen atoms, so I will write the number 6. And I have 2 oxygen atoms. In the right part of the equation, I have 1 carbon atom. I have 2 hydrogen atoms. And I have to count all of the oxygens from both molecules. So in the case of CO2, I have 2 plus 1 from water. So I have a total of 3 oxygen atoms. So to balance these chemical reactions, I need to start putting coefficients next to the molecules so I can multiply the amount of atoms in each one of the molecules. For example, it is a good practice to start with elements that are part of compounds. In the case of ethane, that is a compound because it's made of 2 different types of atoms. But oxygen is not a compound, which is made of the same type of oxygen atoms. So I will leave the oxygen at the end because it's easier to modify the number of molecules without affecting other elements. So if I have 2 atoms of carbon in the left part and just 1 in the right part, an easy solution is to multiply the number of carbon dioxide molecules by 2. So I can duplicate the number of carbon atoms present in the right part of the equation. So to do that, I will write a big number 2, which will be our coefficient. And this coefficient means I have 2 molecules of CO2. So this number 2 affects the whole molecule, okay? So I can multiply this large 2 by the number of atoms that are inside this parentheses. Usually we don't write the parentheses, but I will do it this time so you can understand that the coefficient affects the whole molecule. So these 2 affects all of the atoms inside. So I have 2 plus 1. So now I have 2 carbon atoms in the right part of the equation. But I also affected the oxygen atoms. So I need to take that into account. So I will multiply this large 2 by the 2 here. So I have a total of 4 plus 1 that it's bonded to the water molecule. So I have a total of 5 oxygen atoms now. Okay, so I will erase this. So we simplify the drawing. So remember that the coefficient affects the whole molecule. So I will write it again here too. Now, we have balanced the carbon atoms. We can now move on to the hydrogen atom. As you can see, we have 6 hydrogen atoms in the left part and only 2 in the right part. So we have hydrogen atoms only in the water molecule. So we can multiply the number of water molecules so we can have a total of 6 hydrogen atoms. So the solution in this case, the solution in this case is that you add a number or a coefficient of 3. Oh, sorry, I'm having trouble with the mouse, with the cursor. So I will add the coefficient 3 here, which means I have 3 water molecules. This whole entity, it's multiplied by 3. So I have 3 different water molecules. So this large 3 affects all of the number of atoms inside the parentheses. So I have 2 times 3, which is 6. So in that way, I balance the hydrogen atoms in both sides of the equation. But I have a problem now because these 3 also affects the oxygen inside the parentheses. So I multiply 3 times 1, and I have a total of 3 oxygen atoms plus the 2 plus 2 that I have in the carbon dioxide molecule. So I have a total of 4, which adds to 7. So now instead of 5 oxygens, I have a total of 7. Now you can see the convenience of leaving the molecule, which it's composed of only one type of atom at the end, because I can now go back to the left part of the equation and just multiply the number of oxygen molecules, so I can get the same number of atoms as the right part of the equation. So in this case, the solution is what number multiplied by 2 gives me 7. So the solution is 3.5, okay? So now if I multiply 3.5 molecules of oxygen, O2, I have a total of 7 oxygen atoms. And as you can see in our list, now I have balanced all of the atoms that are part of the chemical reaction. But there is just one tiny problem. It is a weird thing to specify the chemical reaction with not with whole numbers. 3.5 molecules of oxygen, it's a little bit weird to represent. So an easy solution to this is just to multiply the whole chemical reaction or chemical equation by a whole number, so I can have all of the coefficients as a whole number. So the easiest way to do this is just to multiply all of the coefficients by 2. So 2 times 1, here's an invisible 1, because it's just one molecule of ethane. Now these 2 times 3.5, 2 times 2, and 2 times 3. So that gives us a coefficient of 2. I will write it here. Well, it's better if I erase all of this. It was a 3 here. So I will multiply the whole chemical reaction by 2. So I will write it down here. So I have 2 molecules of ethane plus 2 times 3.5 is 7 molecules of oxygen, produces 4 molecules of CO2 plus 6 molecules of water. Okay, so that will be the general explanation of how to balance chemical reactions. In the next video, I will show you how to use a new concept, which is the mole. That is a very useful unit to make calculations with a balanced chemical reaction. Thank you and see you in the next mini lesson.